Hello, students. Thank you so much for joining me again with another math lesson with Mr. Whitford. This lesson is live. It is today. So I'm going to do my best to give it to you as best as we can. Please follow along. You should have your Unit 6 packet with you, opening to lesson 6.4, where we're talking about percent decrease. Let's dive right in. Right away, as usual, with every worksheet, you should take this moment out to begin to work on the bell work, right? You should take this moment to pause the video if you need to, and work on the bell work. It says calculate the percent increase and the percent change of the following. So A is asking you what is the percent to go from 25 cookies to 68 cookies, and B is asking you if there was an 8% increase of students, and we started at 21 students, how many students are there now? All right, take a moment, pause the video to answer the bell work. All right. So I'm hoping that you guys had enough time to be able to look at it and be able to answer them to the best of your ability. Let me walk you through how to do this. Now, today's lesson is percent decrease, but know that the way that you would do it is very similar to how you would do percent increase. So I'm going to go over how to do percent increase for both A and B, and then obviously walk you through the modeling and as well to show you how to do percent decrease. So first of all, if it's going from 25 cookies to 68 cookies, I know there's a percent increase, right? The formula here, once again, to find this would be N minus O, right? N standing for new minus O all over O. Now, new minus original all over original. If you want to write down N is new, O is original, sure, go for it, right? The biggest thing at the top here is just finding the difference between the two numbers. Big number minus the small number, so you can find the difference. Or if you did a small number minus big number, that's fine. Just use the absolute value. You will still get the exact same number, okay? But you do have to put it over the original amount. So new minus original. So that's 68 cookies minus 25 cookies all over the original, which in this case is 25 cookies. 68 minus 25 is going to give us 43 all over 25. Okay. When you divide this, 43 divided by 25, you get a decimal. That decimal is 1.72, but they want it as a percent. Now, remember, in order to find a percent, you can do two things. You can move the decimal 2 spaces to the right, or you could even multiply it by 100. Either way, you'll end up with 172% is the amount that it has increased. And that makes sense, right? If you take a moment to think about it, if I said to you, hey, I have 25 cookies and it's going to increase by 100%, that means it's going to double. So I would end up with 50 cookies. Notice that here it's very close to tripling, which would have been 75 cookies. So it's in between 100 and 200%, right? Which is perfect. Look at B. We originally start with 21 students. They're telling you that there's an 8% increase. So first thing I'm going to do here is find the 8% increase of the students here. What does it look like to have 8% of 21? What does that look like? So the first thing I'm going to do is figure out what 8% of 21 is. That means I'm going to turn 8% into a decimal, multiply by 21. Okay, you could do it this way, or you could do the 8 over 100 equals part over whole, which in this case it would be 8 over 100 equals x over 21. Just to find what 8% of 21 is. That is not your answer, though. Don't stay there and think that that's going to be your answer. So in this case here, right, 0.08 multiplied by 21 is going to be equal to 1.68. So 1.68 is my answer here. 1.68 is my answer, right? This is telling me that 8% of 21 is 1.68. That is not my answer. It's an increase. The word increase tells us that we are adding here. So the word increase means we're going to end up adding that 8% to the original amount. So I'm going to end up doing 21 plus 1.68. And this is going to give me the increase of the amount of students, which is 22.68. But because we're talking about people here, it's best to say that the answer is indeed this is like an approximation, right, line. I can say that there's 22 students, right? I'm sorry about that glitch. Okay. I can say there's about 22 students, okay? only because they're people and we don't want portions of people, okay? All right, so that's how you find it. The answer is still 22.68, but just because we're talking about people, I'm just showing you there's approximately 22 students, really, okay? Let's dive down and talk about percent decrease. Now, the way we did percent increase, take a moment, study if you need to, check your work, edit it, right? Take a moment to discuss it with your fellow peers if you need to at this moment, but really understand how to find percent increase. If we're asking for the percent increase, like in A, you need to find the difference of the two numbers and divide it by the original number, right? Take that decimal and then turn it into a percent. You can either move decimal 2 times, multiply by 100, and B, they give you the percent of increase. I want to know the new amount that is actually there. So first find that percent increase and then obviously add it to the original amount. Now, percent decrease is very much the same. The formula is exactly the same. It doesn't change. When I'm asking you for the percent of decrease or the percent of increase, it's still the same. It's saying find the amount that has changed and put it over the original amount. That's going to tell you how much is either increased by or how much it decreased by. Decrease, however, means how much has actually gone down. So when I find the actual new amount, I'll show you what that looks like in a second. Look at the modeling, right? David moved from a house that is 89 miles away from his workplace to a house that is 51 miles away from his workplace. What is the percent decrease? So what is the percent decrease here? We have David, he's originally at 89 miles. So if you want to know that that's his original or his starting point or wherever you want to call it, that's a good place to go. So you can say original is here. His new area where he's at is actually 51. What is his percent decrease? Notice they didn't give us the percent, so you're looking for the percent. I'll tell you again, the formula for finding this, once again, you can always do new minus old or original all over the original to find the actual percent increase or percent decrease. Now, in this case, you'll notice it's going to be something a little different, but I'm going to walk you through it in a couple different ways to try to explain it to you, okay? Let's just plug it in, 51 minus 89 all over the original, which in this case is 89, okay? But Mr. Woodford, if I do 51 minus 89, that gives me negative 38. That gives me negative 38, Mr. Woodford. And I want you to know right now, you should not be getting negatives. Negatives is not what we're aiming for, okay? So if you get a negative, I want you to turn that into a positive. Why? Because if I were to do 89 minus 51, you would get a positive 38. So in this case, I really want you to know that this here can either be written like this, absolute value, or you could say it's original minus new, right? Either one of these is going to give you the answer at the top, which needs to be a positive number, not a negative number. We're looking for positive numbers, no negative numbers, okay? So if you want to write that somewhere on your worksheet, feel free to do so. Sorry, I'm not sure what I'm doing here. Okay, if you want to write that, like I'm going to write it right here, no negatives, right? Just to make sure we're all in the same place. We don't want negative numbers in our calculations here. We don't want negative numbers, so no negatives, okay? So you once again, you can either do the absolute value because the absolute value of negative 38 is a positive 38, or you could do O minus N, which is 89 minus 51, big number minus small number here. I just tried to keep the formula the same because I want you to have the same technique every single time. So if you want, once again, you can always do big number minus small number. You can keep it as N minus O, just do the absolute value every single time. But you want to make sure the number that's on top is positive, not negative, okay? And then put that over the original amount. So the original amount in this case is indeed our, why it's glitching? Let me try to fix this. Our O. So in this case, O is our original amount. So I'm going to put this over 89. So 38 divided by 89. That's going to give us this decimal of 0.4269. Let me just stop there, 0.4269. And I need to turn that decimal into a percent. Once again, you can either move the decimal 2 spaces to the right. You can either move the decimal 2 spaces to the right. Maybe my sleeve. Yeah, it's much better. Okay. Or you could multiply by 100. Either one, you end up with 42.69%. Okay, this is the percent of decrease. Okay, so they ask you how much percent they decrease, you would say it decreased by 42.69%. Notice the way we found it is exactly the same way we find percent increase, right? In this case, there's no math that you have to do other than n minus o all over o. Make sure the top is a positive number, not a negative number. And then once you divide and get the decimal, turn the decimal into a percent. That is either the percent increase, the amount that it increased by, or in this case, the amount that it decreased by. Okay, which is almost half, right, of 89. It looks like it almost half because 89 is about 90, and it does look like it dropped almost halfway. Okay, look at B. B talks about the grizzly bear. If you need to look at A, pause the video, rewind it, watch it again, have someone in class clarify it. That's perfectly fine. Shout out to my student Mark. I know you're probably gonna do a great job explaining it to the class, and that's okay with me. Okay. B, the grizzly bear population in Yellowstone Park in 1970 was about 270. Over the next 35 years, it decreased by 65%. What was the population in 2005? Now, this is a hypothetical. The one from the worksheet before was factual, but this one is hypothetical. So let's just use it for just calculation purposes. The grizzly bear population in Yellowstone Park was 270. The years doesn't matter. 1970, 35 years, things don't matter. But 270 bears do matter, and it decreased by 65%. Well, what is that? The first thing I want to find out is what is actually 65% of 270. So I'm going to write 65% as a decimal, and I'm going to multiply that by my 270. Okay, I'm going to figure out what is 65% of 270. Okay, what I get is 175.5. 175.5 is 65% of 270. Okay. Now, because they're telling me it decreased, that tells me that even though this is the 65% I'm looking at, I'm not going to add that to the 270. I'm going to actually subtract that to the 270. So I'm going to do 270 minus my 175.5 in order to figure out how many actual grizzly bears are there in 2005. So 270 minus 175.5 gives me 94.5. So 94. Oops. Okay. Don't be laughing at me, children. I know y'all want to. 94.5. Okay. 94.5. Now, obviously, we are talking about grizzly bears. So I wouldn't recommend you put a half a bear. You can say approximately, and this is the little approximate signs, right? 94 grizzly bears. What is going on? Okay. Approximately 94 grizzly bears. Okay. All right. So once again, I would first turn the percent into a decimal, multiply it by the whole, in this case, 270. Find out what 65% of 270 is. That's not your answer, but that tells you how much it actually has to decrease by. So then I know, okay, take the 270, which is the original amount, and subtract the 175.5 from it to find the actual amount of bears now, or in this case, 2005. Okay? This is how you do it. Take a moment to consider it, look over it, review it. If you have any questions, feel free to post them on Google Classroom, or feel free to ask your classmates. I'm hoping that you had a good time, and you guys are intelligent. You guys are awesome. Have an incredible day. Look forward to seeing you next time on Making Math Meaningful.